we just see the basics of the control system so far. I hope you understand the basics of the control system and what should be the behavior of the system when the poles is on left hand side, right hand side on imaginary axis, and what is transfer function analysis, how it will be useful to do the system behavior. Now that we comes under a basic portion of the control system. I hope you understand that one. Then the remaining topics of the control system is also very easy for you. Okay. So this basic portion, and which is very close to another topic of our subject. Now that is called as a second chapter of this control system, that is called as time domain analysis. Okay. Now students, in this time domain analysis, don't think that what is time domain analysis, which we already finished. Whatever we covered so far is comes under time domain analysis. So only I just recollect what is time domain analysis. Okay. Now let us assume just a few responses which we are previously we just take only the impulse response. Now this is the impulse response, now which is exponentially decaying, right? This is impulse response which is exponentially decaying with respect to time. This is with respect to time. Now let us take another impulse response. This is the impulse response This is the impulse response. Now you know this is exponentially decaying. Student, this is exponentially decaying and amplitudes are decreasing. Therefore, this is called exponential decaying and damped oscillations. Exponentially decaying and damped oscillations with respect to time. Students, if the response of the control system, if you draw the response of the control system with respect to time, is called as time response. What is the definition of time response? Note it down. The time response is if we draw the response of any control system with respect to time, is called as time response. This is one time response. This is another time response. Now the question is, sir, then what is time domain analysis? Now you are saying a time response. The response of the control system is with respect to time, is called as time response. And what is the time domain analysis? Now I am asking one question. So this is the response which is exponentially decaying. When I am asking a question, now what about the system behavior? Now what about the system stability? Your immediate answer is, sir, this system is stable, sir. Where there is an exponentially decaying is nothing but negative real part, sir. Negative real part means left hand side. System is stable. Sir, this is also same, sir. Exponentially decaying means e power negative real part, sir. E power negative real part means system is stable. So what you are doing? You just should draw the response of the system with respect to time, is called as time response. After completion of the time response, to evaluate its performance, to measure its performance with respect to time, is called as time domain analysis. Understand or not? Students, you understand or not? If you draw the response of any control system with respect to time, is called as time response. Like this, this is the time response. Like this, this is the time response. After drawing the time response, to judge its behavior, to measure its performance, to evaluate its performance with respect to time, now is called as time domain analysis. Now with respect to time, sir, the system is stable, sir. The performance is response is like this and the system is stable. That is called as time domain analysis. Now what we covered so far will be the same. We draw the responses with respect to time and we measure the performance. So which means that the time domain analysis is completed. Is it right or not? Yes, the time domain analysis completed. So then why again you kept a separate topic as chapter 2 and time domain analysis? Yes. So, but now this fellow is saying that the total time domain analysis, is of two parts. One is transient state analysis. One is transient state analysis and another one is steady state analysis. One is transient state analysis, another one is steady state analysis. Now what he is asking? The total time domain analysis is nothing but transient state analysis as well as steady state analysis. Now I am asking a question, sir, this is the time domain analysis you are saying, this is the time response you are saying. So this comes under transient state analysis or this comes under steady state analysis? Now if you want to clarification of that, now you have to understand what is transient state analysis and what is steady state analysis. Am I right or not? So first we will see what is transient state analysis and what is steady state analysis. After that you come to a conclusion that whatever so far we covered is comes under transient state analysis or is comes under steady state analysis. Now you have to be answer for that. I will explain what is transient state analysis and what is steady state analysis. Now students, the transient state analysis, concentrated here, okay, first. The transient state analysis is nothing but, it is a part of time response, but not. The transient state analysis is nothing but, now this is a part of time response. This is a part of time response, no doubt, because we are concentrated on the time domain analysis means time response. This is a part of time response and this deals with the actual, the natural response. The natural response. Now students, when you can get the response, when you can get the output, the response is coming only when we are giving the input. The actual response of the system after applying inputs. Now what is the transient state analysis? The transient state analysis deals with, it is a part of the time response which deals with the actual response of the control system after applying the input. Now the students, now this is the response. Which response? Impulse response. This is the response. Which response? Impulse response. This is the impulse response. This is the response. This is the output of a control system after applying some input. After applying some input is nothing but this is the impulse input or step input or after applying any input. After applying any input. If you apply any input, see the actual response that comes under transient state analysis, which is a part of the time domain analysis or time response. Students, you understand? So whatever we covered is nothing but we want to draw the response of the control system with respect to time is a time response, but this is the response after applying some input. Therefore this comes under transient state analysis and this comes under, this is also called as a transient response. But no, this impulse response is called as a transient response. Step response is also called as a transient response. Ramp response is also called as a transient response. Parabolic response is also called as a transient response. Any response after applying some input is called as transient response and that particular analysis deals with transient state analysis. Without any doubt, whatever we are doing is nothing but a transient state analysis. Then you ask one question, sir, which means that the transient state analysis is completed? No. Now after applying any input, but so far we applied only one input, that is nothing but the impulse input. That is nothing but the impulse input. But there are, this impulse input is a theoretical analysis, theoretical calculations, theoretical measurement, but there are n number of inputs available, step input, ramp input, parabolic input, but especially the practical existing input is called as a step input, okay, step response. But that step response which we are not covered, because so far what we are doing is theoretical analysis. So far what we are doing is a theoretical calculation, theoretical measurement. Therefore, now not only impulse input, now we will see another inputs also, including the impulse, step, ramp, parabolic. Then that we will finish the transient state analysis completely. Okay. Then you understand, we just covered only a part of the transient state analysis because we are applied only one input which is called as impulse input. Now this is the story about the transient state analysis. Now the student, what is the steady state analysis? This is also completed or not, we just see. Now this is the transient state analysis. This is also a part of time response. This is also the part of time response. Therefore, now what is the steady state analysis is doing? What is the steady state analysis is behaving? Now this is a part of the time response which deals with calculations of errors and steady state error. Let us assume this is also one error. This is a part of the time response which deals with calculations of error. Error is a very important analysis for any response or any behavior or any system, any natural phenomena also. Am I right now? In our BTech examination point of view also, error is important. How many marks I am attended and how many marks I secured. Now what should be the deviation is called as error. What is the pass percentage? How many marks I can get? How much is the deviation? Is error. Okay, so error is a very important. Based on error we can analyze the system performance or system behavior. Am I not? So that error calculations, steady state error is also one error. Final error is called a steady state error. Let us assume this is error. Okay, so this steady state analysis is a calculations of error parts. Okay, so that steady state analysis deals with error and steady state error. Now this is the steady state analysis which is a part of the time response. Now students, if you observed or not, I am giving the definition of error in the previous basic classes of the control system, but we are not doing, sir, error is 10, error is 100, error is 1000, error is 0. We are not doing any error calculations. Okay, so we are not at all touch the error analysis. We are not at all touch the steady state analysis. That's why we are not finished the total time domain analysis. We just finish a part of the transient state analysis, because the response after applying some input, we already applied one input, impulse input, and we already covered one response is impulse response. Okay, so what is the when we can say the total time domain analysis completed? The total time domain analysis is completed now after completion of the transient state analysis and after completion of the steady state analysis. That is the total time domain analysis. Therefore, the total time response is nothing but the transient response as well as the steady state response. Okay, just take a brief overview of this. I hope you understand what is transient state analysis, what is steady state analysis. Note down the student this one. Okay, sir. So now you ask one question, sir, how I can recognize this is a transient term and how I can recognize this is the transient steady state term. That also I will give one easy method to you such that you can easily identify what is transient term and what is a steady state term. By looking the response, you can immediately identify, sir, this is transient term, sir, this is steady state term, sir. You can identify like that. Okay, now this is the transient term and this is the steady state term. Sir, what is the transient term, sir? How I can identify the transient term? Sir, what is the steady state term, sir? How I can identify the steady state term? What is transient term? What is steady state term? How I can identify? Now see, now the transient term is a term limit t tends to infinity whose value will become 0. Limit t tends to infinity, the value will become 0. Now that particular term is called as transient term. Limit t tends to infinity, if c of t or any response or any term is equal to 0, now that term is called as a transient term. Then you understand or not? What is e power minus infinity? E power minus infinity is nothing but 0. Means any term is a combination of exponentially decaying, then there you substitute t tends to infinity, that term will become 0 or not? Now if that term will become 0, that term is called as a transient term, which is very simple shortcut method. If any term is having a combination of exponential decaying with anything, exponential decaying multiplied with anything, now that term comes under transient term. Sir, only exponential term is also a transient term because t tends to infinity, exponential decaying is nothing but 0. Only exponential decaying, not exponential increasing. Okay. Now this is the transient term. Sir, then what is the steady state term, sir? How I can recognize the steady state term? Now the steady state, what is steady state? Constant, am I not? Reference level. There are n number of names for steady state term. Steady state term, I am already saying in the previous class also. Steady state term or steady state value or steady state level or steady state gain or system gain, all are same. Steady state gain or system gain or reference level or final level, final value. Steady state term, steady state value, steady state level, steady state gain, system gain, reference level, final value, all are same. Now this steady state term or steady state value, steady state level, which is a constant level, which is constant for all the values of time, which is constant for all the values of time, whose level, whose magnitude is constant for all the values of time, for all the positive values of time, for all the values of time. Now that term is called as a steady state term or steady state level or steady state gain. Whose magnitude, let us say clarity, whose magnitude is constant for all the positive values of time. Whose magnitude is constant for all the positive values of time, for all the values of time from minus infinity to plus infinity comes under steady state term, and whose value will become 0 at t tends to infinity comes under transient term. Okay, like that you can easily identify the transient term, and like that you can easily identify the steady state term. Okay, the steady state term is a term whose magnitude is constant. Transient term is a term whose value will become 0 at t tends to infinity. Let us give one small question such that you can easily understand. Now by considering the following response, now this is the following time response which is given to you, and identify the transient and steady state terms. Identify the transient and steady state terms. Identify the transient and steady state terms. Now students, you just see here, now this is the time response, it consisting of terms. Now you want to identify which is transient term, which is steady state term. Just now I am saying when you substitute t tends to infinity whose value will become 0, that term is called as a transient term. and I am already giving one shortcut method. E power minus infinity is 0. Therefore, where there is exponential decaying, that comes under transient term. Now this is the exponential decaying. Substitute t tends to infinity. If you substitute t tends to infinity, e power minus infinity, this is 0. If you substitute t tends to infinity, this is 0. This is called as transient term. This is also. If you substitute t tends to infinity, e power minus infinity is 0. This is called as transient term. If you substitute t tends to infinity, this value will become 0. If you substitute t tends to infinity, e power minus infinity equals 0. E power minus infinity equals 0. This is the transient term. Now if you see here, with respect to time, now this is the unit step signal for the positive values of time, and a magnitude is 10, whose magnitude is constant for all the positive values of time or for all the values of time. Whose magnitude is constant for all the values of time is called as a steady state term. Therefore, now the student, this comes under steady state term. And similarly, this one also, you know the behavior of the sine and cos. Now the response is maintained. Now with respect to time, you should draw the response. Now what is the peak amplitude? The peak amplitude is 2. Minimum amplitude is minus 2. This is the peak amplitude is plus 2. Minimum amplitude is minus 2. Peak to peak amplitude is 4. And the frequency of oscillation is 6 radians per second. Now the peak amplitude is plus 2, minimum amplitude is minus 2, peak to peak amplitude is 4, and the frequency of oscillation is 6 radians per second. Now students, if you observe, the response is maintained, constant amplitude, right? Constant amplitude, magnitude is constant for all the values of time. Now this comes under steady state term. This comes under steady state term, whose magnitude is constant for all the positive values of time. Now this is steady state term. Now limit t tends to infinity, e power minus infinity is 0, e power minus infinity is 0, then this term is called as a steady state transient term. I think you can easily understand looking the response, sir, this is the transient term, sir, this is the steady state term. You can easily understand, okay, because the total time domain analysis is possible and is valid, and you can judge the total time domain behavior when you have both the transient state analysis as well as the steady state analysis. Okay, now note down the students. Now students, then you can understand what is transient term, what is steady state term, what is transient state analysis, what is the role of steady state analysis. Okay. So now we will take a complete time domain analysis by considering one standard systems. Okay. Now, by considering the following block diagram, first you find the transfer function. Now this is the block diagram which is given to you. This is the forward path gain, and this is the feedback path gain, and this is the negative feedback. This is the forward path gain, and this is the feedback path gain. Okay, and feedback path gain is the feedback path gain is unity. Whenever the feedback path gain is unity, you have some shortcut method to find the transfer function of closed loop from open loop transfer function. Use that shortcut method. Now this is the closed loop control system transfer function. C of S output by input R of S, which is equal to G of S by 1 plus G of S into H of S. Don't do this method because you have some shortcut method. Why unnecessarily wasting of your time? Then this is assume forward path gain. This is the open loop transfer function. Numerator is same as numerator. Numerator of open loop control system is same as numerator of closed loop control system. And denominator of open loop control system is same as the denominator of closed loop control system plus numerator of open loop control system. This is the closed loop control system transfer function directly. Otherwise you substitute G of S, H of S is 1, you can get the same answer. Now this is the highest power in the denominator polynomial is 1. This is nothing but one of the standard first order closed loop control system. This is the standard first order closed loop control system. This is the standard first order closed loop control system transfer function where tau is system time constant. Where tau is a system time constant. Where tau is system time constant. Where K is system gain, you know that, because the control system parameters are control system gain and control system time constant. Okay, those time constant and the system gain are the parameters which will affect the performance of the control system. Now this is the system time constant. Now this is the standard first order closed loop control system. Now what we are doing is, now I just take one standard first order closed loop control system transfer function. Now I want to do the time domain analysis of which system? The time domain analysis of a first order closed loop control system. Now I want to do the what is the time domain analysis of first order. First I want to see, which include both the transient state analysis as well as time domain steady state analysis. Then after that we will take the standard system second order and again we will do the time domain analysis. Then that is the completion of the time domain analysis topic. Okay, so which include both transient state analysis as well as steady state analysis, students. Now this is the closed loop control system transfer function. Now first order where tau is system time constant. Is it right or not? Now students, then we will start the time domain analysis of first order system. I just changed the topic. Now this is the S, time domain analysis, but of which control system now? Now the time domain analysis of first order system. First order. Clear or not? Okay, then you just take this one and we will go for the time domain analysis of first order systems. Now the students, this is the transfer function C of S by R of S, which is equal to 1 by 1 plus tau S. Okay. Now what we want to do, first we will see the time domain analysis. In the time domain analysis there are two topics. One is transient state analysis, another one is steady state analysis. Now first we will see the transient state analysis. Okay, what is transient state analysis? Response after applying some input. So I want the response after applying some input means, then can I write like this? C of S response, which is equal to R of S into 1 by 1 plus tau S. This is the response output after applying some input. But if you observe, this is C of S, R of S, yes, that is in frequency domain, S domain. But what is our topic? Our topic is time domain analysis. Okay, our topic is the time domain analysis. Therefore, now we want to see the transient state analysis. The transient state analysis is nothing but actual response of the control system after applying some input. Now, in all the previous topics, we just see only one input, impulse input, only one response, impulse response. Now there we will start. Okay, we will start with the impulse input and we will continue in the remaining inputs. Okay, now we'll see with the case 1. Case 1. Now R of t, the reference input as impulse input. Now if R of t as delta of t, what is R of s? R of s is Laplace transformation of delta of t, now which is equal to 1. So now C of s, this is the response. I want the response now. Now this is the response. Now the closed loop control system response. Now what is R of s? R of s is 1. 1 divided by 1 plus tau s. This is the closed loop control system response. This is the response after applying which input? Impulse input. Therefore this is also called as impulse response. This is the closed loop control system response. Now this is nothing but the impulse response. But I want in which domain? Time domain. This is in which domain? S domain. Therefore convert, apply inverse Laplace transformation. So C of S, which is equal to 1 by, if I take tau as a common, S plus 1 by tau. So C of S, which is equal to 1 by tau into 1 by S plus 1 by tau. Then apply inverse Laplace transformation. Then if you apply the inverse Laplace transformation, what is the inverse Laplace transformation? The inverse Laplace transformation of C of S is C of t, which is equal to 1 by tau, 1 by S plus A, e power minus at, 1 by S plus A, e power minus at, A is minus 1 by tau into t. Now this is the impulse response. Am I not? Now this is the closed loop control system response, students. This is the impulse response. In which domain now? This is in time domain. Am I not? This is in time domain. Now this is the response in time domain. Because I want the time response. I want the time response. I want the time domain analysis. Now we want to do the time domain analysis. Now this is the closed loop control system response. Now this is the impulse response. Now C of t, which is equal to 1 by tau into e power minus t by tau. 1 by tau into e power minus t by tau. Now if t equal to 0, now see here, if t equal to 0, what is the response? Now the response, which is equal to 1 by tau e power 0. E power 0 means 1. E power 0 is 1, therefore which is 1 by tau. Now when t equal to 1 time constant, when t equal to 1 time constant, now this is the response, which is equal to 1 by tau. T equal to 1 time constant cancel, therefore e power minus 1. And so on, the response is exponential decaying, t equal to infinity. Therefore this is C of t, which is equal to 1 by tau into e power minus infinity, which is equal to 0. Now what is the response? Now the response, which is exponentially decaying, now the response which is exponentially decaying. Now when t equal to 0, now this response is 1 by tau. The response is 1 by tau. But when t equal to 1 time constant, when t equal to 1 time constant, this is exponentially decaying. When time equal to 1 time constant, where is the response? Now the response is 1 tau of e power minus 1, which is nothing but, now this is 1 tau is nothing but this is the initial value, right? Because this is at t equal to 0, this is the initial value. Now e power minus 1, which is nothing but 0.37 of 1 by tau. 1 by tau is nothing but the initial value. Therefore, when time is 1 time constant, 0.37 of 1 by tau. When t equal to 1 time constant, the response is reaches to 37%. Now see the students, when t equal to 1 time constant, the response is reaches to 37% of initial value. So when time is 1 time constant, the time taken by the response to reach 37% of initial value is called as 1 time constant. This is the definition of time constant in the impulse response, in the theoretical response. Okay. And when t is infinity, now the response is exponential decay, e power minus infinity, this is 0. Now this is the impulse response. In the impulse response, what is the definition of time constant? The time taken by the response to reach 37% of initial value is called as 1 time constant. This is the definition of 1 time constant. This is the time constant definition in the impulse response. What is the time constant definition, student? Note down. The time taken by the response to reach the time taken by the response to reach 37% of initial value is called as 1 time constant. Okay, the time taken by the response to reach 37% of initial value is called as 1 time constant. Now this is the impulse response which is exponential decaying. Now based on this impulse response, you can do the analysis also. Now this impulse response is exponential decaying, and this impulse response which is a stable response, because exponential decaying means definitely it is on left hand side of S-plane system is stable. Okay, now this is the response after applying some input is nothing but the transient response. Now I am asking one question. Now this impulse response consisting both transients, then before you copy of this, then I ask one question and remember that question in your mind. This impulse response consisting both transient state analysis and steady state analysis, and it is having both transient state and steady state, or it is having only one analysis which is transient state or steady state. Now you just have a answer of this particular question, and you think about that particular question, and first you take a copy of that, and that particular question answer we will see after copy of this. Now students, what is your answer? Now this impulse response is having both transient state analysis as well as steady state analysis, or it is having only one analysis? What is your answer? Right? Have any answer in your mind? Then you just go for the clarification of that. Now this is one time response. Now this is the response. This is nothing but impulse response. Is it right or not? Yes, this is the impulse response. Now I am asking one question, student. Identify the transient and steady state terms in this response. When I am asking a question in this response, what are the transient term and steady state term, and I am already giving the clarification. Limit t tends to infinity, if it is 0, that is nothing but the transient response. If you substitute limit t tends to infinity, and where there is an exponential decaying term, is 100% transient response. If you substitute t tends to infinity, now this is nothing but transient term only, because limit t tends to infinity, now the value will become 0. Limit t tends to infinity is substitute, if this is 0, therefore this is nothing but only transient term. Now a question is nothing but this impulse response consisting, this impulse response consisting only which term? Transient term. This impulse response consisting only transient term. Am I right? Not this impulse response consisting only transient term. This impulse response consisting only transient term. There is no, is there any steady state term? The steady state term is a term whose magnitude is constant. No steady state term. The impulse response consisting only transient term, and there is no steady state term. The impulse response consisting only transient term and there is no steady state term. Therefore, the impulse response is not the total time domain. Impulse response consisting only transient state analysis. There is no steady state analysis. You cannot calculate error and steady state error for impulse response, because if you want to measure the error, I want a reference level. Am I not? If you want a error analysis, I want a reference level. But there is no reference level. There is no steady state level. There is no steady state term. If there is no steady state term, there is no steady state level. We cannot find any error analysis. That is the reason why the student in all our previous topics in the impulse response, we just see only response. Draw the response and it will be finished. We are not touch the error analysis for the impulse response. The reason is this, because the total time domain analysis is both transient state term as well as steady state term, but this impulse response consisting only transient term and there is no steady state term. If there is no steady state term, we cannot calculate. Therefore, there is no steady state analysis for which response? Impulse response. There is no steady state analysis for impulse response, because the impulse response consisting only transient term, there is no steady state term. Understand, student? This is very important question. Sometimes in the examination, he is giving impulse response, he is asking error and steady state error. Now after completion of this topic, we will have some error formula. If you do that formula, you can get some answer, but the answer is also available in the option. But you have to remember that if it is the impulse response, no steady state term, no error calculation, no steady state error, because there is no steady state term. That's why this is the third important point, which is very important point. We cannot calculate error and steady state error for the impulse response, because the impulse response does not have any steady state term. The impulse response is having only transient term, no steady state analysis. no error analysis. Steady state analysis means what? Steady state analysis means only error calculation part, no error calculation, nothing, because the total time domain analysis is nothing but transient state analysis as well as steady state analysis. The total time domain analysis is nothing but a transient state analysis as well as steady state analysis, but this impulse response is having only transient term and there is no steady state term. Now this impulse response consisting only transient term. Students, you just see here, this impulse response consisting only transient term and there is no steady state term. Okay, that is the reason why I just give the 3 points, which is very, very important point. Okay, and one more point also I want to say here, this is the transient term, this is the actual response. The actual response, students, if you observe or not, this is the actual response. The actual response is always depends upon system time constant. The actual response, the natural response is always depends upon the system time constant. Therefore, the transient state analysis is depends upon system time constant. The transient state analysis is depends upon system time constant. Students, this is very, very important point. The transient state analysis is depends upon system time constant. Now I have another question. Sir, so this impulse response is having only transient term, no steady state term. But which response is having both transient term and steady state term? Where we can see the total time domain analysis. Now without any second thought, where the response is having a constant steady state level, a standard reference level, a standard value, a constant magnitude. When I am saying these points, in your mind I think you have to get one input. Now that is nothing but a step input or unit step input. Now that is the standard input. That's why that response is called as a practical response. Now this is case 1. We just start with impulse response. Now we'll see the case 2, which is nothing but a step response or unit step response. That will give the complete time domain analysis. There you can find both transient state analysis as well as steady state analysis. You measure the error analysis also. Okay. Now before we see that, then you just take a copy of this.